الله الرحمن الرحيم. In the last part, we spoke about the cross product and we defined the parallel vectors using the cross product, and we said that two vectors are said to be parallel if their cross product equal to 0. And then we discussed the special product or gave some example about the triple or scalar triple product and vector triple product. And we finish with giving the rule for some applications of cross multiplication, and this way where the area of parallelogram was given by the magnitude of A cross P, and the area of a triangle is equal to half of the magnitude of the cross product A P, and also we gave the rule of finding the volume of the parallel bite, was given by the absolute value of the triple dot product A dot B cross C. And we said that if the volume is equal to 0, then the three vectors are said to be coplanar. Today we are going to give examples about these rules or formula. First example of today. Let's find the area of the triangle by the given points. So with that, there are 3 points, B1 given by 0, 0, 0, B2 given by 0, 3, minus 1, and B3, which is minus 1, 2, and 4. And we need to find the area determined by these 3 points. This is B1, 0, 0, 0. B2 is 0, 3, but this is in 3-dimensional. B2 is 0, 3 in Y, and minus 1. This will be down. Third one is B3, which is minus 1 for the x-axis. 2, this is minus 1. The other side, 2 on the y-axis, and 4, it will be up. So we need to find the area of this triangle in a 3-dimensional case. Now, it is in the 3-dimensional space. And to find the area of this triangle, we need just to form the 2 vectors. I have B1, B2, and B3. All what we need to construct 2 vectors that will be the size of the, or 2 sides of the triangle. So I will have B1 to B2, let me call it A vector, and B1 to B3. So let's form the 2 vectors. Then just find the cross multiplication to find the area of the triangle. So let A vector equal to the vector B1, B2. And we said that if we have the initial point and terminal point, the vector will be the terminal point minus the initial point, or the coordinate of the terminal points minus the coordinate of the initial point. So I have B2, which is given by 0. So this will be, the formula is x2 minus x1, y2 minus y1, z2 minus z1. This will be the component of the vector. And since the original, or the initial point is the origin point, so the vector will be the coordinate of the B2. So it is 0, 3, minus 1. This is a position vector. 0, 3, minus 1. Now B equal to B1 to B3. And also this is a position vector. So we just take the coordinate of the B3, which is minus 1 to 4. Minus 1 to 4. Now the area of the triangle will be A equal to half the magnitude of A cross B. Is half multiplied by the magnitude of A cross B. So we need to find A cross B first. A cross B is equal to 0, 3, minus 1, minus 1, 2, and 4. This is equal to 4i, first one, because the first column, first row. So it is 3 times 4, 12, plus 2 equal to 14i. Then minus the second component, start with negative sign. Now for j, cross the second column, 0 times 4 is 0, minus 1 with minus 1 is plus 1, so it is minus j. Third one is a plus k, so cross this one, 0 times 2 is 0, minus 1 times 3 is minus 3, so it will be plus because it will be 0 minus minus 3. So it is 3k. So this 14i minus I minus j plus 3k. So the area now will be equal to half of the magnitude. Which is equal to half. Magnitude is the square root of 14 square plus 1 plus 9. This will be equal to 206. So it is half square root of 206. So the area of this triangle is equal to 1/2 multiplied by square root of 206. So the idea is to create two adjacent vectors, then find their cross product, find the magnitude and divide by 2. That will give me the area of the triangle. Another example. Consider the parallel piped with edges. A equal to I minus 3j plus 2k. B equal to 2i minus j, and C equal to 2j plus 2k. So we have parallel piped. So with that, these are, this is A, this is B, and C there is there. So these are adjacent vectors or edges of the parallel pipe. And we need to find A, find the area of the face given by B and C. So I need to find the area that is given by B and C. It is this one. It is parallelogram. And the area of the parallelogram equal to the magnitude of B cross C. So the area in this case equal to the magnitude of B cross C. So I need to find the cross product of the two vectors B and C. B cross C is equal to B is given by 2i minus j. So it is 2 minus 1, 2 minus 1, and there is no k, means it is 0. For the C, it is 2j plus 2k. There is no I. It means 0, 2, and 2. Which is equal to, for I, cross the first one. So it is minus 2 times, or minus 1 times 2 is minus 2 minus 0. It is minus 2i. Taking this. Now for j. Don't forget that we must start with negative sign. Then we find the product of j. For j, cross the second column. 2 times 2 is equal to 4 minus 0. So this is minus 4j. For k, cross the third one. 2 times 2 is equal to 4. This is 2. Minus 1, so it is plus 4k. This will give me the area equal to the magnitude of B cross C. That will be square root of 4 plus 16 plus 16, which is equal to square root of 36 equal to 6 squared unit. So the area of this space equal to 6 squared units. B, find the volume of the parallel pipe. The volume is given by A dot B cross C. Take the absolute value. The volume is given by A dot B cross C. For the absolute value of A dot B cross C. Now we have B cross C. So the volume is equal to, take the absolute value of A is given by, I will use this notation, bigger and smaller than, it is 1, 1, and 0. This is, oh, sorry, it is not this one. A is given by 1, minus 3, and 2. Back. This is A. 1 minus 3 and 2. And B cross C is minus 2, minus 4, and 4. Minus 2, minus 4, and 4. Take the absolute value. This is equal to minus 2, minus 3 times minus 4 is plus 12. 2 times 4 equal to 8. So this is equal to 18. Cubed units. So the volume for the parallel pipe equal to 18 cubed units. We mentioned one thing before. We said that if the volume, which is equal to A dot B cross C, equal to 0, then the vectors A, B, and C are coplanar. It means they are in the same plane, or you can say they are in the same level. Let's take this one. Example. Determine whether the vectors A equal to I plus J, B that equal to minus I for J, and C, which is equal to 2I 2J plus 2K are coplanar. So I need to check this condition to determine whether they are coplanar or not. So we need to find B cross C or A dot B cross C. So we need to find this one, A dot B cross C. Which is, this is scalar dot product or special product, scalar dot product that given by A1, A2, and A3, that is 1, 1, 0. B1 is minus 1, B2 is 4, K is 0, and C is 2, 2, and 2. We need to find this value and check whether it is 0 or not. The determinant for any matrix can be calculated using any row or any column. So if we choose this column, I have only one non-zero element there. This will be very easy to find. For I it is 0, 0, then I will have 2, the last one. Or the other method is to duplicate the first and second column. It is 1, minus 1, 2, 1, 4, and 2. We duplicate the first and the second column. Then we move diagonally down, from up to down. This is positive, this is positive, and this is positive. This is negative, this is negative, and this is negative. We just multiply this element diagonally. So the first one, 1 times 4 times 2 is equal to 8. It is plus 8. Second one, we have 0, 0. Third one, because this is 0, I will have 0. Now move down to up. The first one, 2 times 4 times 0 is 0. This is minus 0. Next one, 2 times 0 times 1 is again 0. Third one, 2 times minus 1 with minus 1. So this is minus 2. This negative sign, it is this one. You can say this is from the formula. And the multiplication of the number 2 minus 1 and minus 1 is equal to minus 2. Now this will give me 8 plus 2, which is equal to 10. And 10 is not equal to 0. So the vectors A, B, and C are not coplanar. Because the value for A dot B cross C is not equal to 0. So the three vectors are coplanar. So this is the idea for checking the vectors which they are coplanar or not by finding the dot triple product or scalar triple product. So in this part, we spoke about the area of parallelogram, area of the triangle, volume of the parallel pipe, and whether the three vectors are coplanar or not. These are direct application of the cross product of the vectors.